Assalamu alaikum everyone. My name is Hamza Akhtar Siddiqui, reg number 2020147, and today I along with my group member Zaeem will be discussing our final project for the course Fundamentals of Logic Design Circuit. So for our final project, we have decided to make a two-way traffic and pedestrian control circuit. Moving on towards our introduction of our project, we have basically chosen this project so uh, to showcase our abilities to design and making electronic circuits, and we think we will be successful in making a real life application using logic design. So our circuit is basically intended to be used for two one-way intersecting roads. So as you can see in the diagram here, when the horizontal roads traffic light is green, which denotes that the vehicles can cross the intersection, the vertical roads traffic light will be red. And when the horizontal roads traffic light will turn red, it will turn red, flash yellow before turning red. And when it turns red, letting the vehicles know to stop, the vertical roads traffic light will turn green, allowing the vehicles to move in the upward direction. We have also incorporated pedestrian lights along with our project. So when our traffic light is red, the pedestrian light will be blue, which will let the pedestrians know when to cross the road. And when the traffic light turns green, the pedestrian light will turn red, uh, indicating to the pedestrians to stop. Same is the case with the other traffic light. So before starting our project, we had some objectives for our project in mind. Basically, we wanted to incorporate a flip-flop implementation in practical life, and also wanted to research and test out different kind of flip-flop applications, which we have already done. And we wanted ourselves to be able to use different kind of ICs for our project. So in our project, we will be using D flip-flops, and this will be done using uh, the 7474 dual D flip-flop IC. So now I will go through some of the requirements for our project. Basically, our project will include one digital clock, four 7474 ICs, two AND gates. We will be using the 7408 TTL series AND gate. We will also be using two traffic lights, two orange probes, and two blue probes. So, given the current situation of the global pandemic COVID-19 and the online education, we are not able to implement our project in real life. So, we will be using multisim by National Instruments to simulate our project, but our project can easily be implemented in real life by using a breadboard and a trainer board. We have also listed down the specifications for the components we will be using. So we will be making use of the digital clock, which will give clock pulse in input to the 7474 ICs. We will change the frequency of the digital clock according to our need. Secondly, we will be using the dual D type flip flop 7474 IC. We will hardwire this to the toggle state for our project. This IC has one data input and one clock input and preset input and clear input. But we will not be using the preset and clear input for our project. As already discussed before, we will be using the 7408 AND gate and two traffic lights and four probes. So we have also made our made a block diagram for our project to help the audience better understand the working of the project. So as you can see in this diagram, the clock pulse input is given to two 7474 ICs, and basically what we have done is we have divided our project into two sections, one for the horizontal traffic light and the second for the vertical roads traffic light. Basically we get two outputs from these 7474 ICs and we connect them to an AND gate. This allows us to receive one output, and basically in the end we have three outputs which we connect to the traffic light and also give inputs to the probes for used for the pedestrian lights. So we have given opposite inputs to the second traffic light so that when the first one is red, the second one is green, and vice versa. Now, my group member Zaeem will discuss the project description uh, with you.
Bismillahirrahmanirrahim. My name is Mohammad Zaeem Tauqir, reg number 202376. I will be briefing you about our project description. As we know that we are going to use dual D flip-flop ICs and AND gates. We are going to hardwire our D flip-flops in order to achieve the toggle state. We would be connecting the Q node output of the first flip flop to the first to the D input of the first flip flop. This will help us achieve that toggle state. Similarly, for the second flip flop, we will be connecting a wire from 2 Q naught to 2D input. As for the first clock will be first clock would be a set would be an external clock, while the second clock for the second flip flop would be given the connection from the Q naught output of the first flip flop. The output Q from the first flip flop will be connected to a yellow light, while the while the output Q naught of the second flip flop, that will be pin 8, would be connected to red light, and uh, while for the green light we will be connecting an output of uh, an AND gate taking input of Q naught output from first flip flop and a Q output from second flip flop. In this project, we'll be referring that as an X signal. Uh, I've mentioned as shown here, and even in our block diagram, this will be the X signal. We know that D flip-flop is a edge sensitive component, logic component. That means whenever the flip-flop gets a rising edge, it will toggle the outputs. As you can see here, since first Q is responsible to light up the yellow light for first pulse, for the first rising edge, yellow lights turn on, while the red light is also on until the second rising edge arrives. When second rising edge arrives, it toggles the state of the flip-flop, and Q naught 1 or Q naught of the first flip-flops toggles to 1, and the 2Q also toggles to 1, and of these both inputs gives X. So when these two inputs are 1, uh, X will be 1. That will be that will light up our green light. And when the third rising edge uh, when the flip-flop gets the third rising edge, the Q naught 1 will again toggle to 0, while the 2Q will remain 1, as it is clocked by this 1Q naught. So it will only toggle when the 1Q naught rising edge is detected by the second flip-flop. The As for the second traffic light, the circuit will be similar to above, as my partner Hamza discussed in the block diagram. We will only change the uh, output arrangement. Here, the AND gate is connected to the green light, while for the second node, it will be connected to the red light, to make sure that when the green light is lit here, at the same time, a red light would glow over here. Moving forward to our limitation, the only limitation we face that it is difficult to set up exact time for us, as we experience some propagation delay, and due to the ripple carry effect. As you can see here, the 2Q naught is depending on the output of first flip-flop. We have also attached the screenshot of our multi-sim simulation. As you can see here, there will be 4 stages of our project, and all 4 of those are showcased here. Yeah, that marks the end of our project. Thank you for listening to us.
So, before ending our presentation, we would just like to show you our simulation for our project. So, as you can see on the screen right now, I have started the simulation on multisim, and basically we have given a digital clock input to two 7474 ICs, and we have hardwired all the ICs for toggle mode. And for the second and fourth IC, we have given the clock input as the Q naught output of the previous IC. So then we are able to give two inputs, the Q of the second IC and the Q naught of the previous IC, as inputs to a AND gate, and so we get three outputs which we have given as three inputs to the traffic light. And uh, we have just given alternating inputs for the second traffic light. So this concludes our presentation. Thank you very much, and Allah Hafiz.